right. Hello, boys and girls, moms and dads. Thanks for joining me today. This is Mr. Lan again from Heroes Modern School Academy. We are going to be walking through math tutorials for fourth graders and fifth graders as well. All right, so we're going to get started talking about math tutorials for fourth graders and fifth graders as well. So this is Mr. Lan from Heroes Modern School Academy. Thanks for joining me. And right on the board right here, we can see a couple of learning expectations for our fourth grade students. Fourth grade students should be actually capable of counting to 1 million and potentially beyond, up until 100 million right now. You should be able to count up until tens of millions, 100 million. To do place values of 9-digit numbers, 7-digit numbers, 8-digit numbers, 9-digit numbers. A fourth grader should be able to do that. They should understand concept about simple interests. Okay, so if I have a principal amount of money, the principal, and I give that principal to a bank, for example, and the bank is going to give me some kind of interest on my money, they should be able to understand things in those terms. They should be able to do little area calculations. So if you have like a triangle, what is the area of a triangle? They should be able to do that as well. All right, so just a couple of learning expectations for a fourth grader, which I'm going to be walking you through, that you want to use to teach your fourth grader about fourth grade mathematics. All right, so moving on to fifth grade, there is a couple of learning expectations over here for your fifth grader. The fifth grader should be able to count up until 1 billion right now. In other words, they've understood how to count in thousands, in hundreds of thousands, in millions, and then up until 1 billion. And I'm going to show you a couple of tips on how to teach your child how to count up until 1 billion. They're going to understand a critical concept, which is going to be foundational to complex algebraic problems, BODMAS. They're going to understand how to solve problems in an order. There's an order to solving mathematical problems, especially algebraic mathematical problems that may get complicated. And they're in fifth grade right now. They're getting ready to go to middle school. So you should make sure you teach them about this concept. And then we're going to talk about algebra as well. All right, so let's try to get started. So for our fourth graders here, we have only half an hour. And then the remaining half an hour, we're going to be talking to fifth graders. So our fourth graders should be able to count in terms of millions right now. All right, so potentially from 1 million, okay, that's 1 million. It's got 6 zeros to it. It's a 7-digit number. You should be able to count to 100 million. And once your child actually understands the pattern, you don't have to worry about it anymore. They can count to count for as long as they want to count. So what are you going to do that? You're going to tell them, well, let's count in tens of millions to start with. You can say, well, this is going to be 1 million, 10 million. Okay, you can count. So we started with 1 million, 10 million. 20 million. Okay, so that's 20 million. 30 million. Okay, and there is 40 million. Okay, and there is 50 million. And then there's going to be 60 million. And there is 70 million. Okay. And then there is 80 million. All right. And there is 90 million. Okay. And there is going to be finally 100 million. So you can show them how to do that. Then you may want to teach them how to count by tens of millions. All right, so let's try to do that. So let's assume we want to count from 1 million to 10 million, for example. 10 million. So you're going to tell them this is 1 million we're going to count by millions. Okay, 1 million, 2 million, okay, 3 millions, 4 million, 5 million, then 6 million, right? So this is 6 million right now. We go to 7 million, 8 million, 9 million, and 10 million. All right. So doing different portions of it like that in different increments, you can use to teach your child how to count by tens of millions, potentially millions, and hundreds of thousands and tens of thousands, just like we did before. And they are going to be comfortable with their numbers, counting 7-digit numbers, 8-digit numbers, 9-digit numbers, counting up to 100 million at the 4th grade. They can do it. All right. So let's go ahead and talk about the concept of simple interest, because that's going to be really fun for them. And they've got to understand how to calculate simple interests. All right. So to be able to appreciate the concept of simple interest, you want to tell them things about principal. Okay. What is principal? Well, a principal is going to be the amount of money that you loan to a bank, for example, which you expect the bank to give you an interest on. So an interest is going to be pretty much like, well, I'm going to give you this money, Mr. Bank of America or something like that. Please give me back an interest on my money. In other words, go ahead and work with my money. I give you by maybe, let's say I give them $100,000, okay? I give the bank $100,000. After 2 years, the bank is not just going to give me back $100,000 because they've been working with my money for 2 years. They're going to give me an additional money on top of that $100,000. Well, that additional money that they're going to give me is called interest, okay? So we're going to call that interest I, which interest is going to be calculated with this formula. But before we go to that formula, you want to talk about another thing called rate. Okay, so the rate is going to be the percentage that the bank is willing to give me after putting their money with them, after depositing my money with them for a year. So let's assume the rates for this particular bank is about 5%, which means that they are going to give me back 5% of my money after keeping my money with them for 1 year. Now, the question can come to me to tell me what is my interest. Okay, so how much money will I get if I were to loan a bank a principal amount of money, which is equivalent to $100,000 for 2 years at an interest rate, simple interest rate of 5%. How do I do this calculation? Well, the calculation interest, simple interest, is going to be equivalent to P multiplied by R multiplied by time, okay, and then divided by 100. Okay, so you can get your child to commit this formula to memory so they can, calculate simple interest properly. All right, so we're going to try to use this formula to calculate the simple interest that came from this exercise over here. So what is the simple interest on this exercise? Well, I know that my principal is going to be equivalent to $100,000, okay, multiplied by my rate, which is 5, and then multiply by the time, which is in years, 2 years. Okay, and then I'm going to divide by 100. Okay, divide by 100. So when I divide by 100, 0 is going to cancel 0 over here. So I have 1,000 multiplied by 5. That's 5,000 multiplied by 2,000. That's going to be equivalent to $10,000. Okay, $10,000. So that's a way you can teach your child the concept of simple interest. Use that example to tell them, well, I've got $100,000 right now. I want to give my $100,000 to a bank for the bank to go ahead and trade and work with my money. Well, I'm going to give you this money for 2 years, and after 2 years, I want, in addition to the principal, some interest on it. Use that story to teach them about the concept of simple interest. Okay, it's going to be real easy like that. All right, so let's talk about calculating areas right now. Let's talk about another mathematical concept, especially that's going to be foundational for geometry. You got to understand how to calculate areas, and area is the space that a two-dimensional object occupies. A 2D object, okay, occupies. Okay. So if you have a 2D object like a rectangle like this, for example, this is the rectangle. All right. So how much space will this rectangle occupy on my board? Well, that's the area of that rectangle. Okay. So you can use this example right there just to teach them. Well, how do we calculate the area of a rectangle? Well, we calculate the area of a rectangle by multiplying its length by its height, for example. All right, which the area in this case is going to be equivalent to L multiplied by H, length by breadth, or length by height, or whatever you want to call it. So let's assume that the length is about 5 inches. Okay, and then the height is about 2 inches. What is the area of this rectangle? Guess what? The area is going to be equivalent to 2, which is the 5, which is the length, multiplied by 2, which is equivalent to 10 inches or 10 squared inches. It's important to put the unit over there because when you're calculating areas right now, you're going to be thinking in terms of 8 squared inches or centimeters squared. That's another unit that they use in other parts of the world to calculate areas for us. So the area of a rectangle, don't forget, is going to be equivalent to the length multiplied by its height or its breadth over there. All right, let's take another shape. So look at this shape over here. We want to calculate the area of a right-angled triangle. All right, so let's take a look at it. So look at this shape here. So this is a right-angled triangle. All right. A right-angled triangle is going to be a triangle that has one of its angles equal to 90 degrees. Okay, I'm going to bring this board a little bit close for you so you can see it. Okay. So it has one of its sides to be equivalent to 90 degrees right here. Okay. So when you see this little symbol over here, this means 90 degrees. This angle over here is 90 degrees, and that's a right-angled triangle. Okay, all right. So how do we do this? So we're going to ask ourselves the question. I'm going to make sure that it's not too. All right. All right. So let's say this triangle has a base of 5 centimeters, and it has a height of 3 centimeters. What is its area? Well, we can do it in a couple of ways. So we can try to complete this triangle into an imaginary rectangle just like that, and then calculate the area of the rectangle, right? And divide that into 2. We're gonna get the area of the triangle just like that. So let's try to do that. So we know from the last example that the area of a rectangle is gonna be the length multiplied by the height, okay? So area of rectangle will be equivalent to 5 multiplied by 3, which is 15 centimeters squared. Well, guess what? That area of triangle, the area of the triangle will be equivalent to 15 centimeters divided by 2, which is equivalent to 7.5 centimeters squared. So that's one way that we can calculate areas of a right-angled triangle. But it's got to be a right-angled triangle. Okay, so if it's not a right-angled triangle, you cannot use this formula, this approach to calculate it. All right. Another way that we can use to calculate a right-angled triangle is to use this formula here, which this formula is going to be half base times height, which is going to be equivalent to half multiplied by the base, which is 5, and then multiplied by the height, which is 3, which is going to be equivalent to 15 divided by 2. Again, that is 7.5 centimeters squared. We arrived at the same answer. So this answer is going to be equivalent to the same answer. So that's a quick little way that you can use to teach your child about how to calculate the areas of a rectangle, a right-angled triangle, using those 2 approaches. All right. So did you get something for your 3rd grader or 4th grader brother? All right. So let's look at a complex shape right now. So let's try to calculate the area of a complex shape. So if you have a shape like this, okay, and then you have another one like this. Well, that looks like a funny looking shape, right? How do we calculate its area? Or even if we actually want to make it even a little bit funnier, we can say, what about this? Oh, wow. Calculate the area of the shape if this is equivalent to 4 inches, this is equivalent to 4 inches, and this is equivalent to 6 inches. Well, guess what? This is a right-angled triangle. This is a right-angled triangle. So if we calculate the area of this right-angled triangle, we call that A1. We calculate the area of this right-angled triangle, we call that A2. And we add A1 together with A2, we would have gotten the area of this funny-looking shape over there. So how do we do that? Well, for the last example, we know A1 is going to be equivalent to half base times height. So that's half multiplied by 4 and then multiplied by 4, which is going to be equivalent to 16 divided by 2 or 8. Remember, 8 inches squared or centimeters squared. All right, so let's assume they're giving this one to us in inches. All right, what about A2? So my A2 is going to be equivalent to half of this base multiplied by the height, which is going to be half multiplied by 6 and then multiplied by 4, which is going to be equivalent to 24 divided by 2, which is 12 inches squared. All right. So then I'm going to ask myself, what's the area of this funny looking shape over here? Well, that's going to be A1 plus A2. I'm just going to add it together to understand the space on my board that this shape is going to occupy. So that's A1 plus A2, all right, which is going to be equivalent to 8 inches plus 12 inches squared, and then I have 20 inches squared. All right. So that's going to be a cool way to calculate and understand areas. Understand how to calculate areas. They call this the areas of irregular shapes. But lots of times, most irregular shapes can be broken down into a couple of regular shapes. Just like we broke this down into two regular shapes. So two regular shapes, the right-angled triangle is a regular shape. Another right-angled triangle over here is another regular shape. So we broke that complex shape down into two simple shapes. We calculated the area of the first simple shape. We calculated the area of the second simple shape, and then we added both together to get the area of this complex shape. All right. Fourth grade mathematics. So that's a cool little way that you can use to teach your child fourth grade mathematics. There are additional learning expectations for a fourth grader, which are going to be available on our website. Our website is heroesmart.com/school or homeschool.heroesmart.com. If you go to that website and then you click on the menu button over there, you are going to see elementary. And then from elementary, you can click on fourth grade. You are going to see learning expectations for a fourth grader over there. And then you can use those learning expectations to start to teach your child fourth grade mathematics. What if you say, well, I need additional help? Then we have the downloadable version of the fourth grade right now available on the website. You can click on it, just download it. It's going to be there on the website as well. Or you can purchase a paper copy of it from the website. It's going to be all there for you. And in addition to that, there are free video lessons. There are free tools if you sign up on the Heroes Modern School Academy website as well. Plenty of ways to homeschool your child with our program. All right. Now let's go ahead and talk about the fifth grade mathematics section of today's lesson. Okay, so we're going to be talking to fifth graders right now. All right. So in fifth grade, the child is going to be expected to be able to count to 1 billion right now. 1 billion, literally. All right. Which means 1 and then 9 zeros. Okay. So how do I teach my child how to read and write numbers up to the tune of 1 billion? How do I do that? Well, guess what you're going to do? You're going to break it down. You can say, well, let's count by 100 millions, okay, to start with. So you're going to say there's 100 million, okay, 100 million, 200 million, okay. We're going to counts just like that. And then 300 million, okay. Then 400 million, right? Then 500 million and 600 million and 700 million, right? Then 800 million, then 800 million, sorry. There's a couple of more zeros that I need over there. All right, so that's correct right now. So 900 million. And then 1 billion. I need 1 billion. Okay, so that's 9 zeros for me over there. So you can break it down into small increments like that. Help them to count by 100 millions. Then break it down further, help them to count by 10 millions, by the millions, by 100,000s, by 10,000s, by thousands, and ultimately by ones, so they can know how to count to 1 billion, just like that. All right. And once the child actually sees the pattern with which you're counting, they can actually do the counting by themselves. They just understand, well, that's going to be, that's 1 billion, that's 2 billion over there, and they can just compute everything in their minds once they see the pattern. Okay, a billion is going to have 9 zeros to it. Yeah, so there are 9 zeros here. Okay, 100 million is going to have 8 zeros to it. So that's how you can tell. So 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 zeros over there. But by the time you get to 1 billion, you have 9 zeros. In other words, a 10-digit number. All right. So let's talk about the concept of BODMAS a little bit. It's really important, especially when trying to solve complex algebraic problems. You got to have a rock-solid foundation of BODMAS properly. What is BODMAS? Well, BODMAS is a way to teach the child the order of solving algebraic problems. So BODMAS. All right, the B over here stands for bracket. Okay, so there are certain numbers that may be in a bracket. You want to solve those numbers firstly if you encounter those kind of problems. Bracket. Okay, so this is a bracket. This one is called off, which literally is going to be maybe 2 squared or something like that. 2 to the power of 2 exponent. Okay, off. All right. Now this is division. Okay, you know about division already, coming from previous grade levels. Now this is multiplication. Okay, multiplication. And this is going to be your addition. And this is going to be subtraction. All right. So what are we talking about? So we're talking about solving problems, algebraic problems in this order, starting from here. So if you have a couple of numbers in a bracket, you want to solve those numbers in the bracket before you solve the numbers that are potentially division problems. So what am I talking about? So let's assume I have 2 multiplied by 3 and then squared plus 5 minus 3 stops right there, and then there is another multiplication here. Okay, so there's a multiplication here, and let's move the 4 away from there. All right. So what I'm going to do right now is I'm going to solve this one first. That's my B. So that's going to be 4 multiplied by 6 squared divided by 2. Then plus 5 minus 3. All right. So I've taken care of the problem in the bracket. That's solved right now. Then what about the exponent of it? The exponent of it is going to be 4 multiplied by 36 and then divided by 2. So I've solved the exponent of it, and then this is 5 minus 3. All right. So moving on to the D, which is the division exercise, I'm going to say, what is 36 divided by 2? Well, 36 divided by 2 is going to be equivalent to 18. So I can do 4 multiplied by 18 plus 5 minus 3. All right. Then I'm going to go to the multiplication part of it, which the multiplication part of it is going to be equivalent to 4 multiplied by 18, which is going to be, if we do that, let's try to do it here, 4 here, 2, and that's going to be 72. So that's going to be 72 now plus 5 minus 3. So we've done the multiplication part of the BODMAS. Then we're going to do the addition aspect of it right now, which the addition aspect is going to be 72 plus 5, which is 77. And then the subtraction aspect of it, minus 3, which is going to be equivalent to 74. Okay. So this understanding is very, very important. You got to find a way to communicate to your child that if you find yourself dealing with complex algebraic problems, you got to solve the problems in this order. Now, lots of times you may not have a problem that is all-inclusive of all mathematical operators. It may not be inclusive of an addition operator, subtraction operator, a bracket operator, a division operator. It may include just 1 or 2 of it. but understand this order to solve mathematical problems. That's what BODMAS is trying to talk about. Okay, all right, so that's at the 5th grade level. So let's try to apply that understanding to solve a couple of algebraic problems right now. All right, I'm going to keep the BODMAS here still on the board, but I am going to say I'm going to create an algebraic problem. All right, so let us create an algebraic problem that says that multiplied by a plus 2 plus 32 is going to be equivalent to 10. Well, how do I do this? Well, remember inverse operations. So the first thing you're going to talk about is, well, I'm going to say 2 into a plus 2 plus 32 divided by 5 multiplied by 5, because the inverse of 5 is going to be what? 5. Okay? Equals 10 multiplied by 5. So I can get rid of this 5 to start with. So that's going to be 2a plus 2 plus 32 equals 50. Okay, all right. So I am going to now say, well, 2a plus 2 equals 50 minus 32, which is going to be equivalent to, guess what, 18. 2a plus 2 equals 18. All right, so my a plus 2 is going to be equivalent to 18 divided by 2, which is going to be equivalent to 9. All right, so a plus 2 will be equivalent to 9, so a is going to be equivalent to 9 minus 2, which is equivalent to 7. Now, I walked through a couple of concepts in here to solve this problem. I walked through inverse relationships, which we talked about before in prior grade levels. The inverse of division, for example, is going to be multiplication. I walked through the inverse of subtraction, which is going to be addition, and vice versa. The inverse of addition is going to be subtraction. I walked through that as well. So, and I did all that just to show you that everything you're learning right now is going to be building on top of one another. So you're going to let your child know that. So you're learning about BODMAS right now. You are going to find a way to use it later when you get into complex mathematical problems, complex algebraic problems. There are going to be applications of this. So these are building blocks for your child. So teach your child about BODMAS. Teach them about algebraic problems. Create different kinds of scenarios for them. Use those learning expectations on our website to create these scenarios to teach your child about algebra and concept about mathematics. All right, so let's take a look at a couple of other things right now that we may want to learn. Let's talk about statistics. All right. So you may want to teach a child about the mean of a set of numbers or the median of a set of numbers. So let's take the median, for example. So let's talk about the concept of median. Okay. A median, simply put, is going to be the middle of a number, the middle of a set of numbers. So if you have a set of numbers like 5, 2, you have 4, you have 3, you have 7. And they tell you what is the median of this set of numbers. Well, what am I going to do? Well, the first thing I'm going to do is to arrange the number in order. So what that means is I'm going to arrange the set of numbers either from the smallest to the largest or from the largest to the smallest. Well, let's try to do the smallest to the largest arrangement, for example. So the smallest number in the set is going to be 2, and that's going to be followed by a 3, which is followed by a 4, and a 5, and a 7. All right. Then I am going to count how many numbers are in the set. 1, 2, 3, 4, 5. So there are 5 numbers in the set right now. So I'm going to ask myself, what is 5? What is the middle of 5? 5 divided by 2 is going to be 2, 1 over 5. So there are going to be 2 numbers to the left of my middle number, and 2 numbers to the right of my middle number. So what am I going to do? I am going to count 1, 2. All right. So this is going to be the middle, and then 1, 2. All right. So my median is 4. This is the median over here. Okay. The median is 4. So that's how to calculate median, just real quickly. All right. Then they may want to tell you what is the mean of these numbers. You want to teach your child about the concept of statistical means, which, in other words for it, will be the average of these numbers. All right. The mean of this number, of these set of numbers, will be equivalent to 5 plus 2 plus 4 plus 3 plus 7. And then divided by the count. How many numbers are in the set, which is going to be equivalent to 5, okay? 5 plus 2 is 7, 7 plus 4 is 11, 11 plus 3 is 14, and 14 plus 7 is going to be equivalent to 21. So 21 divided by 5, which is going to be 4 1/5 over there. So that's going to be the mean. The mean is going to be equivalent to the average, okay? The average of a set of numbers. Did you notice that when we were trying to calculate the mean of the set of numbers, we did not have to arrange these numbers in a particular order? And that's true. We don't need to arrange the numbers, this particular set of numbers, in some ascending fashion or descending fashion. Why? Because we just want to calculate the mean, okay? So if we're calculating the mean, we don't need to arrange the number in order. All we need to do is just add it all together, divide by the count in the set. All right. What about another concept called the mode? Okay, statistical mode. Well, mode is going to be the number that occurs the most in a set of numbers. Now, these numbers over here have one occurrence each. Each of these numbers occurs once. So 5 is going to be a mode, 2 is going to be a mode, 4 is going to be a mode, 3 is going to be a mode, and 7 is going to be a mode. Well, if you have a set of numbers like this, you're going to call this a multimodal set of numbers. Well, let's assume we have another set of numbers like 5, 2, 3, 2, 4, and 7. Well, for this particular set of numbers, 2 occurs 2 times. So our mode in this set of numbers is going to be equivalent to 2. Okay. So that's how you can explain the concept of median, mode, and mean to your child. What is the median? The median is going to be the middle number. But before you can calculate the middle number in a set of numbers, you've got to make sure that you arrange the numbers in a particular order. You want to arrange the numbers in an ascending fashion or in a descending fashion before you calculate its median, okay? What about the mean? The mean is going to be the statistical average. How do I do that? If I want to calculate the statistical average of a set of numbers, I'm going to add the numbers together and then divide my answer by the count. Okay, that's the number, the total count in the set. I'm going to divide by that. What about the mode? I am going to find my mode by counting the number, by finding the number that occurs the most in that category. That is how I'm going to find my mode over there. All right, so this concept of mean, median, mode, it's actually a 4th grade learning expectation. So you will be well within your rights to start introducing your child to statistical median, mode, and mean concepts at the 4th grade level. At the 5th grade level, you're going to deepen that understanding. You can include larger numbers in your set. So you can say 50, 20, 40, 300, 700. Put it all together, find the median for me. You can do that as well at the 5th grade level, because mathematics is actually a spiral way of learning how to manipulate numbers. So you're going to start with small numbers. The numbers get bigger, you apply the same concept to it, and it gets bigger and bigger and bigger. You apply the same concepts to it as well. All right, so let's talk about how to do multiplications a little bit with larger numbers right now. All right. So let's assume that somebody told us to multiply 325 by, let's say 23, for example. Well, we can get our calculator and just try to make it easy, but before the days that they found that they invented calculators, people used to do this with their aunts, and they were pretty good with it. So how do we do this? Well, you're going to tell your child the way you're going to do it is 325, and then you arrange your 23 under it and put it like this. And you're going to start your multiplication exercise from the right. So this is the units, this is the tens, this is the hundreds. And in this exercise, we may actually need another column over here, thousands, and maybe hundreds of thousands. So you're going to ask yourself, what is 3 multiplied by 5? Well, 3 multiplied by 5 from the multiplication table, we know that is going to be equivalent to 15. So what we are actually saying is 15 over here. You can write your 15 here. Then you're going to say, what is 3 multiplied by 2 over here? Well, what we're actually saying here in this category is what is 20 multiplied by 3. Well, that's going to be equivalent to 60. So you skip another row and you write your 60 right over there like that. Then you're going to say, what is 3 multiplied by 3? Well, what we're saying here right now is what is 300 multiplied by 3, which is going to be equivalent to 900. Well, guess what? I'm going to skip another line and then write my 900, just like that. Then I'm going to go over to this other digits. I'm going to say what is 2 multiplied by 5. But what I'm saying here is what is 20 multiplied by 5. And that's equivalent to 100. All right, so I'm going to write 100 here, just like that. Then I'm going to ask myself, what is 2 multiplied by 2? Well, what I'm talking about right now is what is 20 multiplied by 20, which is going to be equivalent to 400. Okay, so I'm going to write my 400 here. Then I'm going to say, what is 2 multiplied by 3? Well, what I'm saying right now, it is what is 20, because this 2 over here represents the 20. So building on the knowledge of place values from prior grade levels, you can actually start to appreciate all that. So this is 20 multiplied by 3. The 3 over here is going to be equivalent to 300. So you can use that to explain to your child. So this is going to be 20 multiplied by 300, which 2 times 3 is 6, and then you put 3 zeros in front of it. That's going to be equivalent to 6,000. So that's the reason I'm going to put my 6 under the thousands column, and then 0 and 0. And guess what? I'm just going to add it all together. So I add it all together. It's going to be 5 plus 0 plus 0 plus 0 plus 0. That's going to be a 5. And then 1 plus 6, that's going to be a 7. 9 plus 1, that's 10. 10 plus 4, that's going to be 14. I carry my 1 over here, and that's going to be 1 plus 6, and that is 7 for me. So I have 7,475. That's what I've got over there. 7,475. 325 multiplied by 23 is going to be equivalent to 7,475. Now, to prove that we were right, you can tell your child, well, let's learn how to use a calculator. You get your calculator. Yeah, most mobile phones right now have calculator applications to them. So all I need to do is 325 multiplied by 23. All right, so we got it right. So that was 7,475. So little tricks like that can get your child really, really interested in mathematics right from a young age. Okay, so teach them about the concept of multiplication like that. Break it down for them. Teach them about BODMAS at 5th grade. Teach them about algebra. Teach them how to count to 1 billion. Teach them how to do incremental countings. And they are going to be lovers of mathematics, and they will thank you for it. All right. So please go ahead and take advantage of those tools that we got. You're welcome to go to our website, homeschool.herosmart.com. You can download workbooks over there from the website. You can download learning expectations. You can go to register your child for free on our website over there just by typing in homeschool.heroesmart.com/school. You are going to see that sign up button for registration over there. Registration is completely free. It is free. We don't charge anything for it. What do you get when you sign up for free? Well, when you sign up for free, you get a chance to have a structured homeschooling experience right now. Well, what that means is that you get a chance to a structured timetable. You get a chance to a library. You get a chance to an examination module, an optional examination module. You get a chance to the analytics tool over there. What's the analytics tool going to do for your child? Well, the analytics tool is going to help your child when they take an examination to check for strengths and weaknesses. So you can say, well, my child is struggling with multiplication a little bit, so I've got to get more resources about multiplication. Or my child is very good at division over there, but they're struggling with addition and subtraction. It can help you to identify areas of weaknesses and areas of strength to build a well-rounded mathematical student out of your child over there. So that's what the analytics tool is there for on the website, and you can get access to it by just signing up for free and using those resources to your advantage. If you subscribe to us, you can download report cards. There's a lot of things that you can do that we've put together on this website over there, heroesmart.com/school or homeschool.heroesmart.com. And our standard follows the Texas Essential Knowledge and Skills Standards, which we call the TEX standard, because we're from the state of Texas, and our standard follows that, our curriculum follows that standard as well. All right, so that's what I've got for you pretty much, fourth graders and fifth graders. Hopefully you learned a couple of things. If you have additional questions, please feel free to reach out to us at inquiry@heroesmart.com. You can send us an email. You can call us during working hours. 1-800 number is going to be available on our website. You can check us up on HeroSmart's YouTube channel. You are going to see our videos there. They are publicly available. They are free. We are on Facebook right now, just like you can watch this presentation. Multiple ways that you can engage with us, because we're trying to position an average parent to be able to homeschool their children with the resources that God has given us the talent to put together. All right. You get something from it? I sure hope so. Well, thank you for joining me today, boys and girls, moms and dads, guardians and friends. And until next time, remember, God cares about you, and so do we. Bye-bye.